Greetings everyone. We're going to now continue our explorations with Geometer Sketchpad for a very fun and advanced application called morphing. Morphing in a nutshell is taking a particular polygon, in this case you can see in the shape of a lizard or a chameleon, and it becomes another polygon, in this case the polygon in the shape of a dove. And as you can see, we'll learn how to do that. It is possible to morph the chameleon to become a dove. Geometer Sketchpad 5.0 is what you're going to need, and it has some features that allow this fantastic thing to happen rather easily. So please open a new sketch. I already have a page, so I'm going to open in my document options a blank page. And to demonstrate the principle here, I'm going to use a very simple polygon. I'm going to start with, let's say, some kind of a pentagonal shape. And let's say we want to have this become another polygonal shape. Maybe this time it's going to have some other sort of features slightly different like that. Okay, so what we're going to do is we're going to have this polygon morph into this polygon, and in theory you could have any image pasted on Geometer Sketchpad and trace its boundaries in a polygonal fashion. So you could have an image transform into another image using the techniques you're going to learn right now. So what we need to do is we need to select the polygon, go to the construct menu, and create a point on the perimeter. And this point, as you will see, can only move on the perimeter. And what we need to do is we need to measure what is called the value of this point. And in a nutshell, it basically tells you, so this is the zero value. And as you're traversing the perimeter, it's in a sense the percentage of the perimeter that is traversed. Right now, 67, 74%, etc. of the perimeter has been traversed. And what we want to do is we now want to take this value that we plotted, and we want to find an equivalent point on the other polygon. So where would this point map on the other one? So to be able to do that, if we plot the value of the other polygon on this new polygon, you're going to find the counterpart of this point on there. As you can see, as I move this point, the other point also moves. Okay, I'm going to quickly uncheck the names of these points. Kind of confuses me a little bit. Okay, and now comes the interesting part. Let's find a safe area here where we could actually establish a correspondence. Maybe somewhere here. We're going to create a segment between these 2 points. The original traveling point on the original polygon and its mapped image on the other polygon. And what we want to do is we want to put a free point on this segment, and we want to understand, as this point travels on the original polygon, what would this intermediate point trace? What would it look like? And that is constructing a locus. As you'll see, I want to know, as this point travels on its path, what will the locus of this point gonna be? Locus basically means a permanent trace. It's like tracing that point but permanently. And as you can see, let me bring this point to a safer place. As this point travels on the original polygon, the intermediate point travels on its locus, and the final point travels on the green second polygon. We're basically done. Last thing I need is a action button that will move the original point. So I'm going to go edit action buttons animation. And let's have it as medium speed, that's fine. And you will see that as this point travels, the other one also does. And actually, what would be a more interesting animation is have this intermediate point travel on its vertex, on its segment. So let's create actually a animation for that. And you'll see that it will become the second polygon, and then it will become the first polygon as it is traveling. So with this, you can imagine how it is possible to create the original animation that we had. The chameleon is ultimately a sequence of points that define the vertices of the chameleon-shaped polygon. And the same is true for the dove. And let me just actually display the hidden thing so you can see. And you can see how that intermediate point, as it travels between those two segments, is assuming one shape and then the other. So the idea is quite simple, and actually now that I'm thinking about it, you don't really need this animation. This one will suffice. And you can decide all kinds of things about the proximity of these two polygons. If you put one on top of the other and hide and show, create a hide show button for the original polygons, you can actually have all kinds of in-place morphings. But that's the idea, having one polygon morph into the other. Alrighty, the possibilities are endless. You could really have a good time here. I hope you enjoyed it, and if you come up with some very cool variations, please let me know. Send them my way. All the best.